These next few problems, we're going to look at scientific notation, look at the format that we want to write them in, and look at the different examples where we are given small numbers, we want to write them in a scientific notation, or we're given very large numbers and we want to write it in scientific notation. Another slide that we'll look at tonight is where we're given a number in scientific notation and we want to convert back to a standard form. So we'll look at kind of flipping back and forth with different forms. But with scientific notation, notice your example right here. This A term, which is what we will create on every number that we want to write in scientific notation, it's got to be between 1 and 10. It can equal 1. It just needs to be less than 10. And our exponent needs to be an integer. So it's either going to be a positive or it's going to be a negative value. So let's take the first one. We've got 64,000. And what we would like is that A value to be between 1 and 10. Here's where the decimal point is on the number 64,000. Well, what I want is the decimal to be here. 6 4/10 is correct for my A value to be between 1 and 10. Now, what I need to figure out is how many times, if the decimal point is right here, how many times did I multiply by 10 to get to 64,000? Well, if it was 6 4/10, if I multiply by 10, I get 64. If I multiply 64 by 10, I'm at 640. If I multiply 640 by 10, I'm at 6,400. And if I multiply 6,400 by 10, I'm at 64,000, which is where I needed to be. But where should I have started? I should have started right here. So how many times did I multiply 6 4/10 by 10? And it would be 4 times. Let's take the number 2,560. Well, the decimal point is right here on the number 2,560. So my A value would be 2 5600 times 10 to some power. So if I take 2 5600 and multiply it by 10, I get 25 6/10. If I multiply that by 10, I get 256, and if I multiply that by 10, I get 2,560. It's where I wanted to be, but I had to start at this point. So how many times did I multiply by 10? 3 times. So that would be your scientific notation. Now we've got a number that's smaller than 1. So that should tell us that our exponent will be in the negatives because the other two problems both had exponents that were positive, and both of those examples were larger than 1. So where should my decimal point be? It should be 3 5/10. There's my A value. Now, if I'm here, I need to get to a number that's smaller. So what I'm going to do is I'm not going to multiply by 10. I'm going to divide by 10, which is the same as multiplying by 1/10. So 3 5/10 times 1/10, which is the same as dividing by 10, I'm at 3,500. If I multiply by 1/10 again, which is dividing by 10, I'm going to get 3,500. And if I multiply by 1/10 again, which is the same as dividing by 10, I get the number where I originally started. So my A value was 3 5/10. How many times did I multiply by 1/10? Or I could say, how many times did I divide by 10? And that would be 10 to the negative third power. And as we talked about with our negative exponent properties, another way we could write that is times 1 divided by 10 to the third power, because we talked about negative exponents being positive. Both of these are correct, but when you're looking at a scientific notation, you're going to see it written in this way. And one more, we've got this number here, so we've got a very small number. Now, what should my A value be? It should be 5 and 45 hundredths times 10 to some power. Well, we know it's going to be negative. We're just trying to figure out how many times do I have to divide by 10. Well, you start with what we have here is 5 and 45 hundredths. And if I divide by 10 or multiply by 1/10, I'm at 545 thousandths. And if I keep going, need to get the correct number written there. We start to see how many times and I'm almost there. Looks like I'm going to need to multiply by 1/10 or divide by 10. I get this number, and so I'm almost there. And I'm going to divide by 10 one more time. That gives me 4 5 zeros. Very small number. And that should be what we started out with, was 5 zeros preceding the 500, the 5 and 45, 545 value here. 5 zeros, 545. That is equivalent to what we started with. So how many times did we divide by 10? 1, 2, 3, 4, 5, 6 times. So we would write it as 10 to the negative 6th power. So that would be our scientific notation. Now, next slide, we've got 4 examples where everything is already written in scientific notation. We want to put it in a standard. Basically, we're saying, well, we have 6 and 8/10. What happens when I multiply by 10 3 times? I get 68. Multiply by 10 again, I get 680. Multiply by 10 again, and I get 6,800. That's the result of when I take 6 and 8/10, begin with this, and multiply it by 10 3 times. 6 and 8/10 times 10, I come here. 68 times 10, I get here. 680 times 10, I get there, and I have multiplied by 10 3 times, which is what the exponent shows. So what is this? What is the standard notation? It would be 6,800. Here I've got 5 and 25 hundredths times 10 to the negative 5th. Well, all that means is you're going to take this number and you're going to divide by 10. And that's going to give you 525 thousandths. We're going to divide by 10 again. And we're going to do this 5 times. We're going to divide by 10 again. We're going to divide by 10. That's 4 times. So here's the 5th time. So 1, 2, 3, 4. When I divide by 10 on this one, I get here. So I'm going to divide by 10 one more time. And this is my standard form for the example 5 and 25 hundredths times 10 to the negative 5. The negative 5 What does that mean? That means we divided by 10. That means we divided by 10 5 times. Here I've got 2 and 53 hundredths times 10 to the 9th. So all that's doing is saying I'm going to multiply by 10 9 times. So I multiply by 10 one time, I get 25 and 3/10. And I just continue on and on and on. Now, another way to think of that is, well, I'm at 202 and 53 hundredths, and if I multiply by 10, it makes it larger by one place value, two place values, 3, 4, 5, 6, 7, 8, 9 times. When I multiply by 10 9 times, it's creating place values. So what I'm going to have is a very large number. 2,530,000,000 would be the standard form for, and it's a very large number, and that's indicated by a positive exponent. Part B was a very small number, is indicated by a negative exponent. And part D is going to be the same way. It has a negative exponent, so we know we're going to have a very small number. And so if I write my A value, every time I divide by 10, I move the decimal point or the number gets smaller. So there's 2 times, 3, 4, 5, 6, 7. If I divide by 10 8 times, what I have created is 7 additional place values. So what I have here is 1, 2, 3, 4, 5, 6, 7. This is my number that's in standard form from the original. So remember, you can always check the exponent. If you see that it's negative, in this case -8, we're dividing by 10 8 times. We're dividing, taking the A value and dividing it by 10 8 times, which is going to continue to make this number smaller, smaller, smaller.